What are sunspots? The most important thing to understand is that we still have a lot to understand. They appear, disappear, grow, decay, morph around, all seemingly with a mind of their own. We have even found water vapor in sunspots. Much is still a mystery. Recall those bright loops from previous episodes, the ones that leapt up from the surface in perfectly smooth arches and came back down as smoothly as they rose. The strongest and most visible of those loops connect to sunspots, directly to sunspots, in and out of the very center of the dark sunspot, known as the umbra. The intermediate region surrounding that dark central sunspot umbra is called the penumbra, an electromagnetic phenomenon that we are seeing in new ways thanks to the IRIS satellite. Those loops are actually magnetic fields that contain plasma, charged particles, and probably much of the rest of that solar wind material. Those loops only connect at oppositely magnetized sunspots, or those having opposite polar force. The SDO satellite can show us where the sunspot is positive, blue, or negative, red. Loops come out one sunspot and dive down into one of the opposite charge. Makes perfect sense. The charged particles are moving in maintained currents, so one side must be positive and the other must be negative. Now let's zoom out. Here are the arcs, connected to one red and one blue sunspot umbra. A point of interest, the imager that detects the polarity of sunspots is measuring pure neutral iron atoms. It's also interesting to note just how high off the solar surface these arcs tend to go. Let's learn a bit more about IRIS. Thousands watched as she released, fired, and took off for the stars to do its duty. After all adjustments and calibrations had taken place, we were ready to see the sun in a brand new way. Now we are still years from fully understanding what we can now see. The race to know our star is on. For example, there are known energetic oscillations between 3 and 5 minutes apart associated with sunspots, but IRIS allows us to see an energetic pulse that can appear to be emanating from the center every 2 to 3 minutes. What causes this pulsing action, and is it related to the known sunspot oscillations? Maybe you will answer these questions. Consider now that every looping magnetic field arc of charged matter has 2 sunspots to which it connects at the sun, and also that every sunspot indeed has magnetic fields that extend up into the corona. And think about how we saw them shifting and moving and interacting. Well, this causes their fields, their loops, to interact a lot, and sometimes the energetic flows shift so much that the flows entangle. Charged matter gets accelerated to near the speed of light, unleashing a solar flare, a burst of extreme ultraviolet, X-ray, and sometimes even gamma radiation. Solar flares are possibly the most important aspect of space weather, and they are the subject of episode 4.